Hello everyone, welcome to Click to Cloud. In this video, I am going to demonstrate continuous delivery using Spinnaker. Previously, there are many challenges in application deployment, such as need of shorter cycle for production deployment, need to solve increasing complexity in deployment, also to find a robust high velocity solution for executing critical business strategy, and finally should have a strong focus on delivery and deployment. In this demo, we are covering overview of Spinnaker, Spinnaker architecture and services, application deployment using Spinnaker. Spinnaker is an open source multi-cloud continuous delivery platform with high velocity application deployment. Application clusters and server groups are the key concept of Spinnaker. Load balancers and firewall gives how services are exposed to your user. Spinnaker gives the correct way to set an application deployment pipeline in multi-cloud environment. Integration and deployment. We at Click2Cloud have designed our workbench and created a custom cloud formation to design and develop the applications through an automated deployment pipeline. Our workbench provides a customization of infrastructure type with respect to application deployment. Architecture and components of Spinnaker. Spinnaker has 9 main microservices. DEC. DEC is a browser-based UI service in Spinnaker. An end user interact and use services through DEC. By default, it works on port 9000. GET. GET is an API gateway. The Spinnaker UI and the REST API caller communicate with Spinnaker via GET microservices. Orca is an orchestration engine. It handles all ad hoc operations and pipelines. In simple terms, it is an engine responsible for running Spinnaker pipeline and task. Front 50 is used to persist metadata of application, pipeline, projects, and notification. Here, metadata in cloud computing is a small piece of information that can be attached to files and other objects in computing environment. Roscoe is a bakery in Spinnaker. It is used to produce machine image or container image like AWS AMI, Azure VMI, or Google Cloud Images. Eagle is used to trigger pipelines via continuous integration jobs in systems like Jenkins and Travis CI. It adds Jenkins and Travis stages to user in pipeline of Spinnaker. Echo is a Spinnaker eventing bus, sending notification and also act on incoming webhooks from services like GitHubs. Cloud Driver. Cloud Driver is a microservice which is used to integrate and deploy application deployment on various cloud services. Application deployment workflow. In this figure, you will get a clear image on how Spinnaker performs its operation from developer commit to application deployment. First, when developer made changes into his code and pushes his code into the GitHub repository, this triggers CI stage, which is done by Jenkins. So, when the code pushed into the GitHub repository, Jenkins pulls the code and builds the artifacts and upload to Spinnaker. Then Spinnaker triggers from Jenkins and perform backend build from Artifactory. And finally bake the machine image. Now after the performing image building, Spinnaker sets up a suitable cloud infrastructure to deploy our application image through continuous delivery pipeline, and this deployment can be referred to as a production deployment. Finally, all operations such as application deployment on cloud and quality checks at each node is notified to developer through Spinnaker. Now we are moving forward to perform a demo to deploy our test application. Here we are performing application deployment through container service using Kubernetes. Let's move on to Spinnaker. This is our Spinnaker dashboard. Very simple UI but very powerful. So first thing is we need to create an application. The list showing here are previously created application. So we will create a new application here for this demo. So to create application, click on to the action button, then create application, and into the name field give any name to this application. I would give a cube demo name, and this is the name for my application here. Email address would be my email address. Rest everything is optional. Moving forward, our application has been created. So this is just the boundary of our Spinnaker project, nothing more. I have not configured anything yet, nor mapped to anything such as cloud or Kubernetes. Now, as I have Kubernetes installed into my system, I am performing a simple web application deployment using my Kubernetes cluster. First, let's create a Kubernetes load balancer. This is a production load balancer through which we deploy pods in Kubernetes cluster and which is mapped to load balancer service. Go to load balancer, click on to the plus icon. Now in this section we need to give some name to our stack. I'll give prod as my stack name because this is for the production deployment, and expose this stack on port 80. The target port or the backend port is also 80. Now also here we need to mention what type of service we are exposing in Kubernetes. So to do this, click on to the type, select load balancer. Now put rest as dynamic, nothing to be mentioned here. Now click on to the create to create our load balancer. By the time of load balancer creation, let's check our services are running in Kubernetes. Command to check service is kubectl get svc. The load balancer prod that we created is now a Kubernetes service. Into the output, kubedemo prod is the name of our application and the type is load balancer, and this into the pending state. Into the port section, 80 is the target port that we exposed and 30662 is the node port that Spinnaker picked up. I'll check the status by hitting kubectl get svc command again. Now you can see external IP status is giving up an IP. So I will grab the external IP and paste into the browser. This will not show anything because our application that we created is just an empty service. Let's leave it aside. Coming back to Spinnaker, this is our first load balancer and we are set to expose our deployment via this production load balancer. Into the security group section, we do not create any ingress rule. Why? Because this is for the demo and I will leave all security concerns aside. Coming into the cluster, let's create one of the cluster here. Cluster is nothing but the collection of server group. To create a cluster, click on create, give the stack name prod. Now we need to mention what type of container that we need to pull from the Docker Hub for deploying our production app. The moment I type simple, it shows two different images. I will pick latest one, not dev. Select load balancer that we created, kubedemo prod, that is our load balancer. in replica, we can create scaling of our pods. Instead, I will launch 4 pods in my replica set. All this corresponds to deployment our application. Our details are mapped to our application deployment. Moving forward, let's give a name to this container. I will call it as a blue, and my pull policy is always. And finally, as soon as we build our container image, I want Spinnaker to build it, either to pull it. And finally, I may enable a readiness probe. Here, our pods listen on port 80 and path is default because our engine's default homepage is available on root. So nothing needs to be done here, all set. Let's do a quick recap here. Our stack name is prod. Our associated container is simple app latest. We are manually launching 4 pods for deployment. Now this creates a server group. Let's come back and see pods running in Kubernetes on. This is our replica set with 4 pods. Here there is a naming convention given to the pods. kubedemo is the application name, prod is a stack name, VOO is a version, and 4th one is the arbitrary set for our deployment. Now everything is up and running. This is our production app deployed on Kubernetes cluster completely from Spinnaker. Here you can notice that this 4 blocks essentially translates as 4 pods or 4 instances of deployment, and associated with it is load balancer kubedemo prod. This is how you can basically deploy app from Spinnaker. This is a great start. We can create a sophisticated pipeline of continuous delivery using Spinnaker. This completes a small demo on how we can deploy our application on various cloud infrastructure environment. Thank you.